This is a counterclockwise circle, so the carbon number 2 stereocenter is an S stereocenter. Have you ever been trying to solve an R&S stereochemistry question, and by the time you get all of the priority groups labeled and you go back to do your circles, you have no idea which number 1 and number 2 goes with which group anymore? Let me show you a different way that you can assign R&S stereocenters that will work with every molecule, no matter if the number 4 group is in the plane, the wedge, or the dash, and that will always work every time. It's called the A.R.C method. As we start the A.R.C method, let's start with a clean molecule. In fact, that's kind of the point. I invented this method to keep the original molecule clean and do your work elsewhere on the page to make the whole structure simpler to see. There are 3 steps in the A.R.C method. The first step is to abstract the stereocenter, whatever that means. I'll explain that in a second. The second step is to rotate number 4 to be on the dash. And then the third step is to draw our circle and decide whether it's clockwise for R or counterclockwise for S. This is a foolproof 3-step plan for assigning R and S stereocenters every time. Before we get started, let's go ahead and number our carbon atoms. Always a good idea in every organic chemistry problem that you do. Our stereocenters are carbon 2, carbon 3, and carbon 5. These are the ones we're going to assign in this question. The first step is to abstract the stereocenter. What do I mean by that? I mean, take carbon 2, the stereocenter, and abstract it above just the sticks. Only draw the sticks of carbon number 2. So the in the plane groups are down to the right and the left, the wedge is up to the left, and the dash is up to the right. That's it. I would also go ahead and put carbon 2 here, just so that when you go back later, you know that this was abstracting carbon number 2. On these 4 sticks, we're not going to draw the chlorine or the fluorine or the rest of the molecule. All we're going to do is draw the numbers 1 through 4 corresponding to their priorities in the Cahn-Ingold-Prelog system. The chlorine is priority number 1, so we'll draw chlorine as number 1. The fluorine is priority number 2. Carbon number 3 is priority number 3, and carbon number 1 is priority 4. That's it. That's abstracting the stereocenter. Just redraw the stereocenter as is with only the numbers corresponding to their priority groups. If you need some help prioritizing the 4 groups, I have a separate video on that linked down below. The second step is to rotate number 4 to be on the dash. If it's already on the dash, great. If not, we can do rotations to get number 4 on the dash. Here, we'll do a 120-degree bond rotation to get number 4 on the dash. To do a 120-degree bond rotation, we keep all the sticks in the same place. We hold one side of the bond constant, and we rotate the rest of the groups around like musical chairs. If you need a refresher video on that, I have a link to that down below. I'm going to hold number 3 to be constant, so I'm going to keep number 3 in the plane, and I'm going to rotate the rest of the groups like musical chairs. I want number 4 to be on the dash, so let me rotate number 4 to be on the dash. That will bring number 1 up onto the wedge and the second priority in the plane. Now number 4 is on the dash. The last step is to draw our circle to determine whether it's R or S. Number 4 is on the dash. It served its purpose. So we can draw the circle from 1 to 2 to 3, ignoring number 4. This is a counterclockwise circle, so the carbon number 2 stereocenter is an S stereocenter. I would highly recommend writing the letter carbon number 2 is S, so that when you go back to look at it later, and friends, when your instructor goes to grade it later, I know that you're talking about carbon number 2 with this stereocenter. I would also probably redraw it down here as well, that carbon number 2 is an S stereocenter, maybe with even the little arrow to let your instructor know that this is the carbon that you're assigning as S. And that's it. Notice how clean our original molecule is. We did all the work up here, and we didn't even really care what the groups were. All we needed to know is what the priorities are. Let's do this next one. I'm going to abstract the stereocenter down below, redrawing it exactly as is. The in the plane groups are in the northern hemisphere, the wedge and the dash are down below. This is carbon number 3. The oxygen group is priority number 1. Carbon number 2 is priority number 2. Carbon number 4 is priority number 3. And the implied hydrogen is priority number 4. Number 4 is on the wedge, so I can do a 120-degree bond rotation to bring number 4 on the dash. Again, I'll hold number 3 constant and rotate the other groups so that the number 4 group will be on the dash. That will bring number 4 on the dash, number 1 in the plane, and number 2 on the wedge. Carbon number 4 has served its purpose, so now I can circle from 1 to 2 to 3. This is also a counterclockwise circle, so carbon 3 is an S stereocenter. This is an S stereocenter. Let's do our last one. Carbon number 5, we can abstract over here. This is carbon number 5, drawing all the sticks in exactly the same place. All we're doing is abstracting the hydrogen, or extracting the carbon. Priorities, the nitrogen group is priority number 1. Carbon number 4 group is priority number 2. Carbon number 6 group is priority number 3. And the hydrogen is priority number 4. Number 4 is on the wedge, so we can do the 120-degree bond rotation to bring it on the dash. Keep all the sticks in the same place. This is carbon number 5. I'll hold 3 constant, and I'll rotate number 4 to be on the dash. When number 4 is on the dash, that rotates 1 to be in the plane and number 2 to be on the wedge. 4 has served its purpose. Now I can circle from 1 to 2 to 3. This is also a counterclockwise circle, so carbon number 5 is also S. So it turned out in this example, all three of these stereocenters were S. That's an accident. I didn't mean for them all to be S, but this is how we can use the ARC method as a very clean way to abstract all of our carbons, rotate number 4 to be on the dash, and then draw our circle to determine R and S stereocenters.
Thanks for watching. The best way you can support this channel is to let your friends know about these videos, especially ones who go to different schools. Help spread the word around the country. As always, don't forget to like and subscribe.